Welcome to Bitcoin Interview Questions, your comprehensive guide to cryptocurrency concepts and fundamentals. Today, we'll explore the essential topics that every blockchain professional should master. Our journey covers 5 critical areas: proof-of-work consensus mechanism, Bitcoin mining processes, wallet technologies, transaction mechanics, and digital currency fundamentals. These concepts form the foundation of Bitcoin and cryptocurrency knowledge that employers expect during technical interviews. By the end of this presentation, you'll have a solid understanding of how Bitcoin operates as a decentralized digital currency system. Bitcoin is a revolutionary decentralized digital currency that operates without any central authority or government control. Unlike traditional currencies managed by banks or governments, Bitcoin functions through a peer-to-peer network where participants can send and receive value directly. The system is secured by advanced cryptography and maintained through blockchain technology. Bitcoin represents the first successful implementation of digital money that solves the double spending problem without requiring a trusted third party. This breakthrough enables truly autonomous financial transactions across the globe, 24 hours a day, 7 days a week. Blockchain technology serves as the backbone of Bitcoin, functioning as a distributed chain of transaction blocks. Each block contains transaction data that is cryptographically linked to the previous block, creating an unbreakable chain of records. This distributed ledger is maintained across thousands of computers worldwide, ensuring no single point of failure exists. The blockchain acts as an immutable ledger, meaning once transaction data is confirmed and added to a block, it becomes permanent and cannot be altered or deleted. This immutability provides the trust and security that makes Bitcoin transactions reliable without requiring a central authority to verify or guarantee them. Proof of work is the consensus algorithm that secures the Bitcoin network and validates transactions. This mechanism requires miners to solve computationally expensive cryptographic puzzles to add new blocks to the blockchain. The process involves finding a special number called a nonce that, when combined with block data, produces a hash that meets specific difficulty requirements. Bitcoin uses the SHA-256 hash function, where miners must find a nonce that creates a hash starting with a certain number of zeros. This energy-intensive process ensures network security by making it extremely costly for bad actors to manipulate the blockchain. The difficulty automatically adjusts every 2 weeks to maintain consistent block creation times. Bitcoin mining is the process of validating transactions and adding them to the blockchain while competing for block rewards. Miners collect pending transactions from the network's memory pool and organize them into a candidate block. They then solve the proof-of-work cryptographic puzzle by finding the correct nonce value. Once a miner discovers the solution, they broadcast it to the entire network for verification. Other nodes validate the solution, and if accepted, the new block is added to the blockchain. The successful miner receives a block reward of newly created bitcoins plus transaction fees from all included transactions. This process occurs approximately every 10 minutes and is essential for maintaining network security and processing transactions. A Bitcoin wallet is a digital tool that stores private keys and enables users to send, receive, and manage their Bitcoin transactions. Contrary to popular belief, wallets don't actually store Bitcoins themselves. Instead, they store the cryptographic keys needed to access and spend Bitcoin recorded on the blockchain. There are several types of wallets available. Hot wallets remain connected to the internet for convenient access, but with increased security risks. Cold wallets operate offline, providing maximum security for long-term storage. Hardware wallets are physical devices that store keys securely, while paper wallets involve printing private keys on paper for offline storage. Each type offers different balances of convenience and security. Every Bitcoin wallet contains cryptographic key pairs that enable secure transactions through digital signatures. The private key is a secret number that must be kept confidential and secure, as it provides complete control over the associated Bitcoins. From this private key, a corresponding public key is mathematically generated using elliptic curve cryptography. The public key is then processed to create a Bitcoin address, which can be safely shared with others to receive payments. Private keys are typically 64 hexadecimal characters long, while Bitcoin addresses are shorter, alphanumeric strings beginning with specific characters. This asymmetric cryptography ensures that only the holder of the private key can authorize transactions, while anyone can verify the authenticity using the public key. Bitcoin transactions follow a three-step process to transfer value between users. First, the sender creates a transaction specifying the recipient's address and the amount to be sent. The transaction includes inputs referencing previous transactions that gave the sender control of the bitcoins being spent. Next, the sender signs the transaction using their private key, creating a digital signature that proves ownership and authorizes the transfer. Finally, the signed transaction is broadcast to the Bitcoin network, where nodes validate the signature and transaction details. Once miners include the transaction in a block and add it to the blockchain, the transfer becomes permanent and irreversible. The recipient can then spend these bitcoins in future transactions using their private key. Bitcoin operates as a truly decentralized digital currency with no single authority controlling its network. Thousands of nodes distributed worldwide maintain the system, ensuring resilience against censorship and single points of failure. Bitcoin possesses several core properties that distinguish it from traditional currencies. It has a fixed supply cap of 21 million coins, creating scarcity and potential deflationary characteristics. The transaction history is completely immutable once confirmed, providing permanent settlement finality. Transactions are pseudonymous, offering privacy while maintaining public verifiability on the blockchain. The network operates continuously without downtime, enabling global accessibility 24 hours a day, 7 days a week, regardless of traditional banking hours or geographical boundaries. Congratulations! You have now mastered the fundamental concepts behind Bitcoin and cryptocurrency technology that are essential for technical interviews. You understand blockchain as a distributed ledger technology that maintains transaction records across multiple nodes. You've learned about proof of work as the consensus mechanism that secures the network through computational puzzles. The mining process for block validation and reward distribution is now clear to you. You comprehend wallet technologies for key management and secure storage. Transaction mechanics and the cryptographic processes that enable value transfer are within your knowledge base. Finally, you grasp the core characteristics that make Bitcoin function as a decentralized digital currency. These concepts provide the foundation for more advanced blockchain and cryptocurrency topics, positioning you well for technical discussions and interview scenarios.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.